Week 8 just finished up. Week 8, so weeks, 7 weeks left after spring break. Security class. We did some notes from Palo Alto, finished up the lab, and I don't know how far the students got getting started on the LAN. We'll do get started with Chapter 6, Endpoint LAN Security, figuring switches and looking at a lot of different options, network access control, and so forth. So we're really looking at the edge there coming in. Risk came up again. We'll talk more about that later. We listed these terms first and then ask who they were, and so these are people, or a different way to categorize different types of people performing criminal acts, or, you know, between that white hat, black hat, and gray hat in between. These are mostly black hats. Money affiliated with trying to do things to affect, you know, state affiliated. The Tor that come out of Russia there would be an example where Russia's trying to affect our elections, either through social media or whatever. Hacktivists typically have a political view. Anonymous fits in that category. And create terror. Now this could come from maybe any of these above, but you try to create terror within a group. An example would be if you brought down a power grid for a long period of time. Just think where we'd be at if we weren't going to have electricity for 30 days in the middle of the summer or in the middle of the winter or whenever. Okay? This is a way to look at how to approach how any of these would approach, any of these up here would approach an attack. Recon, that goes everywhere from doing very legit research on things to where you're getting into things where you really shouldn't be. But it's this large discovery. Once you do that, if you have a particular target or whatever, or you're just randomly looking for targets, then you can weaponize. What tool are you going to use to do the attack? Deliver the tool, execute the tool. Now, you might have a great tool. You need to deliver it. You can maybe do that through phishing. And then when somebody clicks on the link, they've just created an exploitation. The exploitation might install some software, backdoor, rootkits, whatever. Then you can turn systems into command and control centers. Probably the easiest way to look at that is on botnets or bots. You take control over a large amount of computers. They talk back to this control center server in order to perform whatever mischievous thing maybe up here that you want to do. And that's this right here. You actually take action on the object. Whether that app, maybe it's just a distributive denial of service attack. You're a hacktivist maybe, and you attack a particular political entity that you want to disrupt. Now, a couple important things here too. You can have lots of command and control servers, and so they can vary. So if somebody takes down one of them, then there's just another one to take over. Okay. Another thing we talked about too, as you once you take control, there's lots of different ways to hide your information so that intrusion prevention systems might not see them. A simple example would be encrypting your traffic. Okay. The Palo Alto curriculum has modules 3 and 4. I talk about these particular things. We should have covered most of that, some of it in the beginning security class. Chapters, some of the beginning security chapters, and those that have had data information assurance should have that information. So that would be a great to browse through, see where you're at on those. In Module 5, we talk about network security models. Before, the two models we emphasized were perimeter-based and zero trust. We'll try to get an idea of those. But before looking at those two models, security compliance. This chapter has a whole list. In this section, there's a document. It's only a couple pages, but it has a list of some of the more type of compliance that you see. So like HEPA and FERPA and those type of things. HEPA for the health and FERPA for the education and so forth. Perimeter security, the whole idea of firewalls, as an example, became very popular, especially right after 9/11, as an example. To protect the edge so people couldn't get in to networks. And that worked well up until, more recently, where the networks are a lot more dynamic. They change a lot more. We've gone from just looking at packets to looking at traffic in general, the whole stream of traffic, or we talked about atomic, to looking more composite. Thinking about that. To where now we have a zero trust environment in which there's nothing that you really trust as your traffic moves. Going back here, we have when we first thought, years ago, and actually this actually worked pretty well, is you build some type of firewall that only allows, to give an example, so if I have traffic come through the firewall going out, well, then that built a way for that kind of traffic to get back in. But it doesn't manage the traffic that's inside moving to other places inside. So we get the terminology here: east, west, north, south. Traffic. Okay, we're going to talk more about traffic here in a second, so let's move to the next slide. To build, to better understand our traffic, okay, we build some type of security model in order to do that. Assets and where are they located? Can we build security boundaries around them, and then figure out what our risk is? for those. And then figuring risk is tough. You know, you can quantify some things, but other things you can qualify. But it's hard to measure. In some cases, it's pretty easy to measure. You're going to lose X amount of dollars and so forth. And then a little review on risk. You can get insurance. You can try to mitigate it yourself. You can just accept the risk and some variation in between. What the security model does for us, it gives us some measurable threat prevention. Okay? And we may not take all of the risk away, but by coming up with a security model, at least we have a measurable threat prevention of what we're going to do. And a big part of that is creating a security policy. So in Zero Trust, we have no default trust. Whether you're going from users, applications, etc., 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 there's no default trust. So you're always measuring the north-south traffic and the east-west, right? I'll mark those again. North-south, would be the east-west, right? If you want to do that, consider looking to the north. Okay. This is really important. It's one simple word, but it's this whole idea. I guess another way to mention that would be if I called it also data classification. You know, understanding your data, it's almost like putting it in. You can't do it exactly. Certain buckets, you know. This data, if everybody saw it, won't hurt anything. This data, nobody should ever see it. And then, you know, everything in between. Okay. This is important. Okay. How can you segment this, like this traffic internally to figure out when we authenticate people and then authorize what they can see and then keep track. Right? Everybody should know that. So we want to become aware of all that I just talked about in terms of our traffic, and then become responsive. Okay. When something isn't correct, what do? So we create inspection policies. How are we going to be aware? And then enforcement policies. This is what we're going to do when we see, you know, when we have a certain policy, this is going to enforce that policy. I guess that's a good way to put it. Let me use another color here. So this is going to enforce these policies. These policies we can figure out by being aware, and then we respond. Hopefully that makes sense. Least privilege. Make sure, you know, as you, if you think about this, okay, so we're going to segment the data. We're going to have policies concerning that. We're going to have some type of policies of enforcement if that data is not being managed correctly and so forth. So we got it all classified. What you want to do is figure out security profiles. As an example, certain people should only be able to see or manage or manipulate certain pieces of data. Least privilege. Okay, don't give them more privileges than anybody needs. A physical analogy is certain people don't have keys to the buildings. They can't get in the buildings. Okay? Only a small group of people might have keys for the buildings. You know, your maintenance, CEO, and maybe some other high-end people can move among them and get in and out of buildings. But all the other employees, they can't get in the building unless it's during regular work hours. You know, when the door is automatically open or whatever. So then you have these profiles to make sure you're embracing least privilege. And then you imply or have the enforcement of those. And nowadays, for example, the building access, you know, at NIAC, we have our name badges, which have a barcode or some kind of code on the back, and so forth. And the buildings can be set up that based on security profiles, certain people can have access to certain doors. It doesn't even have to be all the doors, a certain door on a building. And same thing when you move through a building. Okay, you have some profile of where you need to be able to be, and then you can apply that nowadays. General term would be privilege bracketing. All right, that's probably enough for today. We are moving forward then with. Okay, so some more. We'll actually be working with some terms like endpoint security. We're going to do some work with switches, and hopefully with also some access points. And another thing we could do, we do have some cameras. We could do a little experimentation with some cameras and software to manage those. So this would be, it's going to be Chapter 6 in the Cisco curriculum. And then we should finish up fundamentals. Here in the next week. Not a lot to do, but that would be those last 3 chapters. I already talked about quite a bit in Chapter 5, so that'd be Chapters 6 and 7. That's it. Oh, by the way, let me do this. Get some green in here. Spring break. Enjoy your time, at least some of the time, during spring break. That's it.